Determining the direction of velocity in uniform circular motion. The coin will be thrown off in the direction of the tangent, which is perpendicular to the radius of disk. Thus, the direction in which it gets thrown off depends on its position at the moment of getting thrown off. It means that as the coin moves along a circular path, the direction of its motion is changing at every point. Example 1. An athlete is running on a circular track. He runs a distance of 400 meters in 25 seconds before returning to his original position. What is the average speed and velocity? Given. Total distance traveled equal to 400 meters. Total displacement equals to 0 as he returns to his original position. Total time equals to 25 seconds. Average speed ? Average velocity ? Average speed equals to total distance covered upon total time taken equals to 400 upon 25 equals to 16 meter per second. Average velocity equals to total displacement upon total time taken equals to 0 upon 25 equals to 0 meter per second. Example 2. A motorboat starts from rest and moves with uniform acceleration. If it attains the velocity of 15 meter per second in 5 seconds, calculate the acceleration and the distance traveled in that time. Given. Initial velocity u equals to 0. Final velocity v equals to 15 meter per second. Time t equals to 5 seconds. Acceleration a equals to ? From the first equation of motion, a equals to v minus u upon t equals to 15 minus 0 upon 5 equals to 3 meter per second square. From the second equation of motion, the distance covered will be s equals to ut plus 1 by 2
80 square.
S equals to 0 into 5 plus 1 by 2 3 into 5 square equals to 0 plus 75 upon 2 equals to 37.5 meter.